Hello, magandang umaga o hapon sa inyong lahat. We will now be discussing more on triple integrals in rectangular coordinates. So last time, we defined triple integrals with the physical interpretation that it is the mass of a solid given that the integrand is the density at any point xyz of the solid. And we also evaluated triple integrals of functions over solids that are of type xy. So now we will discuss solids of type xz and solids of type yz. So let's recall when is a solid of type xy. And this is the more common solids that we will be considering in this class, right? Because this is more natural that you project something to the ground, no? And our ground here is the xy plane. So a solid is of type xy if there is a projection onto R and wait lang. Ito. So this is there's a projection onto the xy plane and this is R. And if you have a point xy on R, then you can define the uh, the floor of the solid, which is defined by this surface g1 of xy, and the ceiling of the surface, which is defined by another surface g2 of xy. And therefore, we can rewrite now the triple integral as the double integral over the projection R of the single integral of the same integrand, and the limits of integration of the single integral are respectively the lower limit would be the floor of the solid and the upper limit will be the roof of the solid. So because we're treating this as a solid of type xy, then the projection is onto the xy plane and therefore you are the the elevation variable is being integrated. That's why the integral in the innermost part is with respect to z. Okay, next slide. So what is now a solid of type xz? So a simple solid G is of type xz if it lies between two surfaces with equations g1 of xz and g2 of xz for all points xz in the region R, that is the projection of the solid onto the xz plane. So therefore, tinitingnan mo siya dito, no? And then you project it onto the xz plane, which is this, and this is the projection R. And then you can say that this is indeed a solid of type xz if at all points xz on R, you can define with a single surface the how do you say this? You can still call this as the floor and the ceiling of the solid. Okay, so remember that the floor is always the smaller number. So you are looking at the y-axis, right? You can think of the solid as something that propagates along the y-axis. Therefore, the lower limit of integration should be the smaller number, right? This is the lower limit, and the upper limit would be the bigger number, which is here. This is the upper limit. Okay? So, because the terminologies floor and ceiling is quite ambiguous here, so the lower limit will be the smaller number, and the bigger number would be the upper limit. The solids of type YZ, on the other hand, has a similar definition. So, it is of type YZ if the solid is between the two surfaces G1 of YZ and G2 of YZ. And you can project, so if you look at uh, the solid from this angle, you can project it onto the YZ plane. And for all YZ on R, you can uh, define the floor and the ceiling of the solid by one function. So here, the floor would be g1 of yz, and the ceiling would be g2 of yz. So this is a solid of type yz. Okay. So how do you evaluate solids of type xz and solids of type yz? So so solids of type xz would be a double integral again over r dA, but this r is on the xz plane. This region here is on the xz plane. That means that the innermost integral will be an integral with respect to y. Okay? And in the same way, the triple integral of a function over a solid of type yz can be written as a double integral over the region in the yz plane of a single integral with respect to x. Okay? dA. Okay? So in the next part of our discussion of our lecture, we'll look at concrete examples of how to solve the triple integral of a function over solids of type xz and yz.